All right, this section is all about classifying triangles, and we're going to classify triangles by using either their sides or their angles. And so if you want to take a triangle and classify it by its sides, we have equilateral triangles. They would be labeled like this because all their sides are the same, right? All sides might be 5. Okay, if all the sides are 5, we would know they were equilateral. An isosceles triangle has 2 sides are the same. So if we knew that side was 8 and that side is 8, doesn't matter what that side is, let's say it's 5, then we would call that an isosceles triangle. And then we have a scalene triangle labeled something like this, where all the sides are different, right? This is like 12, this is 10, and this is 7 or something, okay? So we can talk about triangles based on their side lengths: equilateral, isosceles, scalene. Or we can classify triangles by their angle measurements, okay? We have equiangular, which means this triangle, all 3 angles are the same. I do want to make a point, and I know we will discuss this later, but these 2 things are identical, okay? Meaning, if you are equilateral, you are equiangular. If you are equiangular, you are equilateral. So really, remember, that's a biconditional. Both of those things are true. This is a good review of proof. So you are an equilateral triangle if and only if you are also equilateral. So what you could do, if you know you're equilateral, you are also equiangular. If you are equiangular, you are also equilateral. And not only are you equiangular, we also know that since they're all the same, they do all have to be 60 degrees, because we know that something plus something plus something has to equal 180, and they're all the same thing. So we get 3x has to equal 180, and you can show that each angle does in fact have to equal 60 degrees. Okay, we have acute triangles, and I tried to draw just a random acute triangle where angle 1 and angle 2 and angle 3 are all 3 of them are less than 90 degrees. So this could be like 50, 60, and 70, or 50, 50, and 80, whatever, doesn't matter, right? An acute triangle is by definition just all 3 angles are less than 90, right? Its counterpart, an obtuse triangle, has one angle that's greater than 90 degrees. So this angle is certainly greater than 90 degrees. And then we have right triangles, where in fact we have one right angle. You know, obviously it's impossible to have 2 right angles. Okay, so right angles, or right triangles, obtuse triangles, acute triangles, equiangular triangles, which by default then also are equilateral triangles, isosceles triangles, and I know it's the next section, but I also want to point out that if you are an isosceles triangle, we do know that those base angles are also the same. Again, that's the next couple sections, but might as well just throw it out there now that we do know that. And then we have scalene. Okay, so in this section, you will label things. You'll use these facts to kind of, solve problems. But I did want to mention that if you are trying to prove something's isosceles and it was on a coordinate grid, so let's say you had a triangle here, or a point there, excuse me, and let's say you had something like that, and you wanted to know whether or not that triangle was actually isosceles. Well, the only thing you have to do is you have to prove to me that that guy and that guy are the same length. Now, as a reminder, how are you going to find length? Well, you're going to use the Pythagorean theorem that says a squared plus b squared equals c squared. So what you might do is that for that length, remember, you might go over and down, and then over and down, and you have to prove that those are actually the same length by looking at, that's 1 and 8, and then that's something else and something else, okay? And if you want to prove to me that they're the same length, then you know they're isosceles, because that's the definition of isosceles, okay? Same thing for a right triangle. So you have something like that. There's your triangle ABC. It sure looks like this is a right angle, but, how do you really prove it? I shouldn't say prove, question mark, maybe proof, question mark, but whatever. Okay, so actually there's two ways. There's one way that they want you to do now, but they don't really think you know the Pythagorean theorem lots of times, but we know we do. And we also know that the Pythagorean theorem is a biconditional, meaning we know that a right triangle is a right triangle if and only if, the double arrow, this is true. And we will do this in future sections as well, but you might as well start with it now. So for me, if you want to prove this is a right triangle, you can find that length A, that length B, and that length C, and if you can show me that this is true, then you can prove to me it's a right triangle. Okay, the other way, so one is Pythagorean theorem, and the other way is slope. Okay, so how do you show that? Well, find that slope and find this guy's slope. We know how to find slope, and compare. Okay, how do these slopes have to be related? Well, if you want that to be a right angle, you need those two lines to be perpendicular. Those lines are only perpendicular if their slopes are opposite reciprocals. So let's say you found the slope of A, and I don't know, let's say that was like a 4/3 slope. Well, then if you found B and you found its slope was negative 3/4, you'd say check mark. Those two slopes are opposite reciprocals, which means they're perpendicular, which means the angle is 90 degrees, which means, of course, it's a right triangle. Okay, so for our class, there are two different ways to prove triangles are right triangles. You can use the Pythagorean theorem and look at lengths, or you can use the slopes of, in this case, you don't care about the slope of C, you just want to make sure that the slope of A and the slope of B, right, these two are opposite reciprocals of each other, thus perpendicular, thus right. Okay, most of the time I think the key will look at slopes right now, and we'll wait till I think maybe even unit 7 to start looking more at the Pythagorean theorem. Okay, so you have different types of triangles by their side lengths, by their angles, and then you have problems associated with, you know, being isosceles or being equilateral or being right, and there are the occasional proofs where you have to look at that.